Hello everyone, my name is Adrian Fernandez from Texas Instruments, and I'd like to give you a quick tutorial on how to use the TI LaunchPad development kits to read real-world sensor data and send it to the cloud using PubNub. So in this case I'm using the TM4C ARM-based launchpad. However, this tutorial will also apply to the MSP launchpads as well as the brand new CC3200 launchpad, which features embedded Wi-Fi. But in this case, I'm using the TM4C123 launchpad microcontroller board here. In order to get this guy talking to the cloud, I'm going to be using the CC3100 Wi-Fi booster pack, and they interface through this booster pack connector here. So I'm just going to plug these two boards together, and they have a physical connection over an SPI serial interface. So I'm just going to plug those two boards together. And this will more or less enable me to start talking to the internet with this two-chip solution. To interface with the various sensors, I'm going to be using the Grove-based booster pack from Seed Studio. So we've been working with Seed Studio the last few months here to develop this booster pack board, and this will work on any of our Launchpad kits to enable the Launchpad to interact with Seed Studio's huge portfolio of Grove modules. They have, I think, over 130 different Grove modules, and we worked with them to create this starter kit here, which features 10 of our favorite modules, such as this ultrasonic sensor, relays, the segmented digital display, among other things. So I'm going to be using 4 sensors from that starter kit for this demo here. So let's go ahead and plug this onto our Launchpad. There we go. Now we can start interfacing the various Grove sensor modules to our Launchpad. The ones that I'll be using here today is a potentiometer knob. So I'm going to plug this potentiometer to one of the connectors of the Grove-based booster pack. And what's really nice about the Grove-based booster pack is that each of the connectors are nicely labeled. So I can very easily see that the potentiometer knob is being plugged into pin number 23. And that's going to be helpful to me when I start writing my software. So potentiometer. I also have an ambient light sensor, and that'll be hooked up to this adjacent port. And again, the label tells me that the ambient light sensor is hooked up to pin 24. I also have a moisture sensor, and this here will allow you to measure the moisture in soil. So you can stick it into your flower pot perhaps. So again, plugging it into the Grove booster pack here, I can see that my moisture sensor here is hooked up to pin number 25. And then lastly, I have a PIR motion sensor. So I'm going to go ahead and take that and plug that into the connector as well. And this PIR motion sensor is hooked up to pin number 26. So I've got pin 23, 24, 25, and 26 all hooked up to my 4 sensors here. And just like that, our hardware is more or less set up. We've got the microcontroller interfacing to the 4 sensors, as well as to the Wi-Fi booster pack. So this goes to show just how simple and easy it can be for creating hardware solutions through this modular approach. And what's really nice is that this is also fairly affordable. Each of the modules here from Seed Studio you can buy a la carte from their website. Or you can go ahead and grab the starter kit, which includes 10 modules plus the Grove-based booster pack. The Launchpad here starts at just $13 US, and then the Wi-Fi board on top is, I think, $19 US. So fairly affordable considering how much functionality is available in this combination that we've enabled here. So that's it on a hardware perspective. We can now turn our attention to the software, but before we can do that, let's go ahead and plug our TM4C launchpad to our computer over USB, and that's going to apply power to the board as well as serve as an interface to the PC, and that's going to allow us to program it, debug it, and even enable communication to and from the computer with our launchpad. So that's it on a hardware perspective. Check out the next video where we'll take a closer look at the software which will be developed using the Energia IDE.